स्टार्ट हो रहा है. So let's start. Sorry for the delay. I'm audible, right? Okay.
Yes, you are audible.
Just give me a minute. Okay, so probably the meeting will be, I think our discussion will end in 1 hour. And after that, the recording will get uploaded on the YouTube. So if it's okay with you, you can check there also. So this is the first problem. In this problem, we are given that chef is building an airport and there are n planes, and the ith plane we are given 2 times, that is the arrival time and the departure time for the ith plane. So we have to find that, first of all, contest has ended, right? Okay, I think there is a lag.
Yes.
Yeah, it's ended. So we are given 2 times, the departure time and arrival time, and finally we have to find what is the minimum number of runways that are required so that each of the plane can arrive and depart without affecting any other plane. So how many people were able to solve this problem? Just write a yes or no in the chat. Okay, so basically this is a very standard problem. Why I'm asking this? So that we don't waste our time on this problem. So in this problem, if there are 5 planes which are arriving at, let's say, some x minutes, and some other 3 planes are also departing at x minutes, so we are going to need 8 runways, right? So basically, let me okay. If at exit minute, let's say there are 3 planes arriving, and at the same minute there are 4 planes departing, so we'll need 7 minutes, right? So in this problem, you just have to find at each minute, like at some minute, what are the total number of planes departing and what are the total number of planes that are arriving. You add these 2 values and finally you'll check if your answer variable is less than this value, then you'll update your answer to this value. So that will give you the minimum number of runways that are required. Is it okay? Or someone needs me to go in detail? This is making sense to everyone, right? Yes, no, anything? Okay. See, first of all, let's go through the problem statement once again. So in the problem statement, it's mentioned that there are n planes such that the ith plane arrives at the aith minute and departs at the dith minute. Now we have to find the minimum number of runways required at the airport so that all the arrivals and departures can occur smoothly. So basically this means that for each plane, like if there are 2 planes that are scheduled to be arrive at, let's say, 6th minute, so at 6th minute there should be at least 2 runways. So then if there are, let's say, at 7th minute there is a plane which needs to arrive and there are 2 planes that are going to depart, so we need at least 3 runways, right? So that all of these 3 planes can be processed simultaneously. So that is what I was trying to explain here. So if you have, let's say, at the exit minute, you have 3 planes arriving and 4 planes departing, you just need 7 planes according to this exit minute. So for each of these minutes, just try to find the sum of the planes that are arriving and that are departing. If the sum of these two values is less than your answer, that is the variable that you are maintaining. If it's less than your current value, just update your value. Is it clear now? Yes, no, anything? Is it clear? Okay. What about others? It's clear to everyone. Okay. Okay. So let's look at the implementation once. Mm. Let me copy my code once. Okay, is the code visible to you? Okay, it's visible, right? So this is basically, I have taken a count map, then I'm taking A and B as input. So for each of the minutes that are given to me in A and B, I'm incrementing my count key in my count map, right? Finally, I've taken my answer variable initially to be 0, and then I'm taking maximum of answer and y. Y is nothing but the count of how many planes will be departed or will be arriving at exit minute. Finally, I'm printing my answer. Is it clear? This is clear, right? Okay, so let's move to the second problem. So this is the second problem. In this problem, let me get it. Okay, so in this problem, we are given that we have n empty boxes and there are m different colors numbered from 1 to m. So now there are AI balls of the ith color. So each distribution of these balls into the n boxes is valid if each ball is placed in a box. Like we cannot leave any ball, and all the balls in a box are of different colors. So we cannot have more than m balls in a box because there are only m different colors, right? Finally, we have to see if, like, over all the valid distributions, we have to find the minimum number of boxes that are having m balls. Okay, so I'll explain what this means in a moment. So under the given constraints, we have, like, it's guaranteed that at least one valid distribution always exists. So first of all, how many people were able to solve this problem? Just write 1 or 0. 1 means that you were able to solve this problem, and 0 means that you weren't able to solve this problem. Okay, I'm getting majority of the ones. Okay, it's nice. So let's see what this problem is. See, we have n boxes and we have m colors. Then for each of these m colors, we have a number that this ball, let's say we have m as 3. So we have 3 colors, and let's say the first color, like the number of balls of first color type is 6. Then we have 3 for second color and 5 for third color. So now we have to arrange these balls. So like, I think n should be at least 6 in this case. So we have to arrange, like, we have to put these balls in all of these boxes such that, like, and a valid distribution is this box shouldn't have 2 balls with same color, right? If any box is having at least 2 balls with same color that are having same color, then the distribution is not valid. Otherwise, the distribution is valid. Now we have to find, out of all of the valid distributions, we have to find what is the minimum number of boxes that can have m balls? Like that is, they are having all colored balls, all of the balls that are like a box can have at max m balls, right? It cannot have more than m balls, because if we have m plus 1 balls in a box, that means at least 2 balls have same colors. So we want that boxes that are having the maximum balls that they can have are as less as possible. So we can do this problem in many ways, but what I did is, see, we can have at max like m minus 1 balls in all of these boxes without any problem, right? Is this making sense? We can have because we don't want m balls, we can have m minus 1 balls, right? Yes, no, anything? Okay, so now see, the maximum number of balls that you can place in all of these boxes without any problem is m minus 1 into n. If you are given these many balls, you don't have any problem. You have a way of arranging these balls in some way or another. How m minus 1? Because see, m balls would mean that this has all the balls, like all of the balls, each ball of like each colored ball is, each type of color is inside this box, right? Each type of colored ball, m would mean this thing. And this also means that in the problem statement, we have to minimize number of boxes that have m balls. So first of all, let's try to fill all of the boxes with m minus 1 balls. We don't want boxes to have m balls, right? So let's try to fill each of these boxes up till m minus 1. Is it clear? Okay, so now if you have m minus 1 into n balls, you don't have any problem, right? Now if there is one more ball, you have one more ball, so now there will be at least one box which has m balls. If you have two more balls left, there will be at least two boxes which have m balls, right? Apart from the, like after this, all the boxes will have m minus 1 balls. If you have plus 1, like this, these were the total number of balls, you will have at least one box which has m balls, right? So what you can simply do, first let's find like the total number of, okay, let's not, like, let's calculate this value m minus 1 into n, and if my total is nothing but sum of all the values of a, that is the number of balls that I have, I is going from 0 to n. So my answer is this thing. Just make sure that in case my total is less than this value, you don't have to output a negative value, you'll have to output 0. So we'll output maximum of these two. Is it clear?
Sorry, sir. Can you repeat?
Okay. So
Total
see,
part.
okay, this total is nothing but the total number of balls that you have. You have only these many balls, and these number of balls can be placed without any problem. So first you place these many balls, and if the total, like the total number of balls are more than this balls, then those number of boxes, exactly those number of boxes will be filled up to m. But if you have only 3 balls and this values turn out to be 100, that you can fit 100 balls without any problem, that means without any box getting filled up to m balls, then you don't have to output minus 97, you'll output 0, right?
Yes, sir. Got it.
Okay, so let's go to the implementation. So this is the implementation. In this, first I'm taking n and m as input, then I'm taking array a as input. So this is the total value, that is the total number of balls, and this is just another variable, so let's call it var. So this is m minus 1, this is nothing but 1ll. 1ll means long now. So just to make sure that this multiplication doesn't cause overflow, so m minus 1 times n, and then I'm printing maximum of 0, ll means long, or total minus var. Is it clear? Yes, no, anything? Like I'm pretty sure that probably some of you would have solve this problem in a better way. Okay, so let's go to the third problem. Okay, let me clear this writing area.
Hello.
Yes.
एक्सप्लेन कर दो एक अगर एग्जांपल n इक्वल टू 4 m इज इक्वल टू 3 होगी और बॉल्स 4 4 4 होगी.
Okay, so did you join right now or were you
No, no,
part
no.
of this? Okay, what part you didn't understand?
No, मैंने अपने हिसाब से किया था, वो नहीं समझ आया वो कैसे गलत है. क्वेश्चन एक बार रिपीट कर दो कैसे होगा.
What did you do?
मतलब n इज इक्वल टू मान लो 4 है
Yes.
और m इज इक्वल टू 3 और m की वैल्यू है 4 4 4.
Okay, these are the number of balls. Okay.
Yes, yes. Okay, अब इसको मतलब कैसे आंसर क्या आएगा इसका अगर हम
इसका probably the answer number of boxes will be 3.
लेकिन 2 आ रहा था मैंने जब आउटपुट किया था रन.
Okay, for you it was 2, right? Your code gave 2.
नो नो जब मेरा जब कॉन्टेस्ट हो गया उसके बाद मैंने करेक्ट सबमिशन देखा था वहां पर ये दिया था तो 2 आ रहा
Okay,
था.
let me see. Okay, let me run my code once.
नो नो सॉरी n इक्वल टू 5 है m इज इक्वल टू 3 है. यस n 5 है.
So then it will be 2.
यस हाउ ये पूछना.
Like you actually want me to draw, like I'm not going to draw it, but the answer, like if you follow my approach, you'll see that m minus 1 into n, this is 3 minus 1 into n is 5, so this is 5 into 3 minus 1, it's 2, 10.
नहीं क्वेश्चन के हिसाब से ऐसा नहीं है लेकिन फर्स्ट बॉक्स में 1 बॉल डाल दी पहले 4 4 डाल दी पहले 4 बॉक्सेस में बॉल्स.
You are trying to fit one of the method, like one of the ways to place these balls in those boxes, and then you are saying that that is the most optimal. That is not the most optimal. Like probably this will be the most optimal. N is equals to 5, m is equals to 3, 4 4 4. So you have 5 boxes. Let's say these are your 5 boxes. So let's say I have first, this is first, this is second, and this is third. Let's say these are the colors. So let's have 1 1 1 1 2 2 2 2, and then let's have 3 3 3 and 3. So there are only these 2 boxes. Okay, but you don't actually have to do this, because this is, you cannot actually always, like you can if you have a correct way, because I have followed my way, like the way I implemented this solution. First I tried to fill all the boxes using m minus up to m minus 1 balls, and then I filled these 2 places with 3 three colored balls, right? But maybe your approach wasn't right. Okay.
Okay then.
Okay. So let's. Yes.
So just like, can we do, like what was I was trying to do, like that first I will fill one in all the row, one there, and if there is like another pillar is left with an empty space of that end, like of that,
if
then
you
I will
try
fit
to
again
fill,
to.
you get TLE. You cannot
Yes,
actually
yes.
go and start filling, because these values will give you TLE. You cannot, like, yes, I get your approach is valid, but still you cannot actually stimulate the actual balls, like where these balls will end up. Okay.
Yes, sir.
So let's look at this third problem. So this is the third problem. In this problem, we are given that we have a string S of length n, and our task is to convert this string into a non-empty palindrome. So a non-empty palindrome is a palindrome which has at least 1 character. So we can use the following operations any number of times. We have to select an index, and once we select that index, we have to remove the characters which were present at the previous index, current index, and the next index. And finally, we can output yes if it's possible for us to convert the string into a non-empty palindrome, otherwise no. So how many people were able to solve this problem? Just write 1 or 0 in the chat. Okay, so let's see what's happening in this problem. See, first of all, let's say n is your length of string, length of the string. Okay, now if n percentage 3 is equals to 1, what will be my final answer? Yes or no? What do you think? What about others? What do they think? Will my answer be yes or no? Okay, so why is it going to be a yes? See, if I have n percentage 3 is 1, so let's say n is 4, so I have 4 characters, right? So I can always remove these 3 characters, or let's say if I had another 3 characters, I can remove all of these characters and I will always be left with only this character. So a character, only a string with which is having only one character, the answer is yes, right? Because it is a palindrome and it is a non-empty palindrome. So for this case, my answer is always yes. Now let's look at the case when my n modulo 3 was equals to, let's say 2. So if my n modulo 3 was 2, so let's consider, okay, so right now my n is 11. Right? Length of this string is 11 and n modulo 3 will give you 2. So see, let's say I'm not removing any of my characters from beginning. I can always remove 3 characters using one operation, right? I cannot remove any random number of characters. I can only remove 3 characters which occur next to each other. So I can only remove the 3 characters which are occurring one after the other, right? I cannot remove any random characters. Let's say I cannot remove these 3 characters, or I cannot remove 4 characters. I can only remove 3 characters. So let's say I'm like, I'm starting, like I'm not removing any of the characters from here. So what do I need? I can either see if I'm not removing any characters. So at the end, let's say I'll always have, I can remove 3 characters. At the end, the string that I'm going to be left with, it, let's say this is the n dash. N dash modulo 3 will also be equals to 2, right? My parity cannot change if I'm always removing 3 characters. So n dash is the final length of the string after removing some 3 characters many times. Many times, or sometimes, or maybe 0 times. So now see, if this is my starting position, I can also remove these 3 characters, right? And if this originally was a palindrome, after removing these 3 characters, I will also be left with a palindrome only. So it's enough for me to just check if this character is same with maybe this character, then I can remove all of these characters. Since n percentage 3 is 0, if I remove these two characters, I will be left with exactly that number of characters which is divisible by 3, right? So I can remove these characters like 3 at a time. First three characters, then these 3 characters, then maybe these 3 characters. So the thing just that I need to check is, first of all, just check that if this character is equals to this character, then you also need to check that whether this character is equals to, you can remove 3 characters, right? So maybe you remove these 3 characters, or maybe this character was equals to this character. Similarly, you also need to check that if this character was equals to this character. Why? Because you can remove these 6 characters, right? Using two operations. So now, finally, you need to check that if this character is equals to this character. If any of these is true, your answer is going to be yes. Otherwise, you can remove these 3 characters. You can only remove multiple of 3s, right? Number of character in multiples of 3s. So let's say you remove these 3 characters. So now you'll have to check this with this, then with this, and then with this. Then you removed another 3 characters. So you'll have to check for which character, like you'll have to check for 6 because you removed these 3, then these 3 characters, and then you'll have to check for this. So for this, you'll have to check this with this, then this with this character. So see, this character is always getting checked for all the positions that are occurring before this character and which are multiple of 3, right? First 0, then 3, then 6. So what we can do, we can insert this first position, 4th position, 7th position, and 10th position in our first 4, 7, 10. These have a difference of 3 in our multi-set. Or you can do it in other ways also. So you can insert these characters in a multi-set, and then what you can do, you can check, okay, start from this character. If you have this character in your multi-set, your answer is yes. Otherwise, go ahead. You can go to this 3rd position, just move 3 indices ahead and remove this character from your multi-set. Then again check whether this character is in your multi-set. If it is in your multi-set, output yes. Otherwise, go ahead. Go 3 characters ahead. So you go to 6th place. So once you go to 6th place, remove this from your multi-set, this character which was at 4th index in your multi-set, remove it, and then start checking for this. If this character is in your multi-set, your answer is yes. Otherwise, no. Is it clear? Yes, no, anything? Okay, and now there is one more case when n%2 was equals to 0. So for that case also, it's pretty same. What we need, see, first of all, when n%2 is 0, we will finally have 3 characters left. Why? Because let's say n is 9. So then we have something like this. We can remove 3 characters using one operation. So let's say we remove these 3 and these 3. So we'll be left with 3 characters finally. And we cannot remove any characters further. So if n%2 is 0, we are left with 3 characters. So in that case, we can simply check, like we'll follow the same operations, like the same kind of approach that we did earlier. But now there is just one more thing. See, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have n is equals to 9. So if this character is equals to this character, then I can remove all of these, right? Otherwise, I can also check that if this is equals to 1, 2, 3, this 5th. Why? Because see, here I have 4 characters. So I'll remove 3 out of those, and the other character which is left, let's say this is the character that is left, and this and the character at the 0th index and 5th index are same. So I can have, let's say those are the 0 characters. So this is a palindrome, right? I can have this character, whatever, like irrespective of this character, it is a palindrome. So that's why if n%3 is equals to 0, in that case, instead of checking for 1 and then 4, I have 2 and 5, and this pattern will continue. So after 5, it will be 8. And then again, you'll check for this character, insert all of these 2, 5, 8, 2, 5, 8 in your multiset, then jump from 0 to 3 and remove the second character from your multiset. Again, check for 5 and 8 if any of these character is equals to this character. If it is, output yes, otherwise no. So I think this will be much more clear to you if you look at the logic for the implementation. See, first of all, I'm taking n as input, then I'm taking string s as input. So if n percentage 3 is equals to 1, I'll output yes and simply continue. That is, go to the next test case. If n percentage 3, n modulo 3 is 2, I have declared a multiset and I'm going through all of the indices starting from 1 and I'm incrementing with 3. So from 1, I'll go to 4. Then from 4, I'll go to 7. I'm inserting all of those characters in my multiset. So this f is nothing but it's a flag for me to check whether my answer is yes or no. So I'm starting from my 0th index and I'm incrementing by 3. So for 0, after 0, I'll go to 3, then to 6. So for each time, I'm checking if s of I, like this character, is in my multiset, my f is 1. And one more thing, like what we were doing here, see, from 0th index, we went to 3. But when we went to 3, we were removing this character, which was at first index from our multiset, right? When we went from 3 to 6, we were removing this 4th character from our multiset. So when we are going to next position, we'll be removing this I plus 1th character. So when we are going from 0 to next iteration to 3, we'll be removing this I plus 1. So if I is 0, I plus 1 is 1. So we'll be removing this character from our multiset. Finally, if f is 1, we'll output yes, otherwise no. So if neither n modulo 3 is 1 nor n modulo 3 is 2, that means our n modulo 3 is 0. So if n modulo 3 is 0, I have again inserted all of these characters which have a difference of 3, which have a difference in their indices as 3 in a multiset. But earlier we started from index 1. Now we are starting from index 2. And the rest all is same. Instead of erasing that I plus 1th character, I'm erasing I plus 2th character. Why? Because here we were checking 0 and 2, right? And when we went from 0 to 3rd character, that is the 3rd index character, we removed this 2nd index character from multiset. So this is what is happening here. And finally, if f is 1, I'll output yes, otherwise no. Is it clear? Okay. Okay. So let's go to the next problem. Just wait for a second. Okay, so this is the 4th problem. And just give me a minute. Okay, so in this problem, we are given that we have n cities connected via road and such that they form a tree-like structure. So our task is to build AI towers in the ith city, and one or multiple towers can be built. That means that AI can be more than 1. So this is one or multiple towers can be built in a city only if there is a brick factory present in that city. So initially there is only a brick city present at the city indexed 1 or city numbered 1. So we have two kinds of operations. Type 1 is construct a tower in a city that has already brick factory, and type 2 is construct a brick factory in a city which has any of its neighboring cities index already, which such that any of its neighboring cities already have a brick factory. So, and neighboring cities are the cities which are connected via roads. So we have to find the different, like all the different number of ways to complete this project such that the total number of operations performed is as low as possible. And since this answer can be very large, we have to output it modulo 10 to the power 9 plus 7. So now, first of all, see, we have something like this. Let's say initially there is only a brick factory at this city. This is my first city. This is my second, third, fourth. This is fourth. This is fifth, and this is sixth. And now, let's say the number of towers that are required for this city, it's 2. Number of towers required here are maybe 1. Here it's 0. Here it's 5. Here it's 0, and here it's 0. So first of all, do I need a brick factory at this city? Yes, no, anything? Okay, I need a brick factory at this city. What about this city? Do I need a brick factory at this city? No, right? Because I'm not going to build any tower here. What about here? Do I need a brick city, brick factory here? Yes. Why? Because if I don't have a brick factory here, I cannot have a brick factory here. But since I need to make some towers at this city, I need a brick factory here. So if I need a brick factory here, I should have a brick factory at this place also. And I don't need a brick factory at this city. So this graph, instead of drawing this, I can also consider this graph as following. Like I can remove these cities. Why? Because they don't have any, I don't have anything to do with those cities. Now, first of all, what are the, like how to get the minimum number of operations? Minimum number of operations. See, by minimum number of operations, we mean that we are not idle for any, after doing any operations. Let's say if X operations are required in total, and what is X, by the way? X is nothing but total number of towers that needed to be built, total number of towers that are needed to be built, plus number of cities that are having that, in which you have to build towers, number of cities in which tower needed to is to be built, minus 1. Why minus 1? Because in city 1 you already have that brick factory, right? And in all of the other cities you will be required to build a brick factory. So let's say you'll work consecutively, like you won't stop after any operation. So this is the total. Let's say each operation is taking 1 minute. So these are the total number of minutes, which is the minimum time required to complete this project. Now, what you need is, okay, you'll start from this position. Okay, so after each second, either like, let's say you have a brick factory and you require 1 tower to be built at this place. So either you can build a tower at this place immediately, or you can start by making a brick factory at this city. After that, you can also make a brick factory at this city, but you don't require any tower here. So either you can build this tower, or you can move to this city and make a brick factory. So what we are doing in this case is, now I'm drawing only those cities in which we have to make a brick tower. Otherwise, if let's say there is also this city and there was this city connected to it, and these cities had, like, you don't actually were required to make brick towers here, because in both of these cities the number of towers that are needed to be built are 0. So in that case, you don't actually have to consider these cities, right? So I'm not drawing these cities. So now let's consider that these are the cities that we are actually concerned about. So let's say there are some number of towers, let's say X, that are needed to be built here, Y towers are needed to be built here, Z towers are needed to be built here. And there are some towers that are needed to be built at this city. But initially, there is only one factory, brick factory at this place, right? Okay, let's make this example a little more easier. So this is what we have, and let's say we have X number of towers that are needed to be built at this city, Y number of towers that are needed to be built at this city, and Z number of towers that are needed to be built at this city. So let's first look at when we go at this place. So if we can see this city, like these Z towers as, okay, for this, I'm marking my towers as square. For this city, I'm marking my towers as circle. And for this city, I'm marking my towers as triangles. So, and also making a factory, brick factory. Let's say for this city, it's plus. I don't actually have to make a brick factory here, but let's say it's plus. For this, it's minus. And for this, it's, let's say it's a multiplication sign. So for this city, let's say there are these Z number of towers that are built. So now for this X city, let's say there is one way that I can get these are the number of towers, possible way to get these X towers. So, and there is also this minus. Why? Because first I'll have to make this brick factory at this city, and then only I can make these towers. So now you can see this problem as you have 4 elements in one array, 5 elements in another array, and you have to merge these 2 arrays, making sure that the relative order remains same. That if after this element, let's say this element is 2 and this element is 3, and if in your original array 3 is coming afterwards after 2, so in your final array, after merging these 2 arrays, you should get 3 after 2. So and how to do, first of all, how to make sure, like how will you combine these 2 arrays? How will you find total number of ways to combine these 2 arrays such that the relative order remains same on these elements? See, if an array has n elements and another array has m elements, total number of elements are in the final array are going to be n plus m. So if, let's say this is your n plus m, if you are able to select m positions out of this array, you fix second array elements at these places, all is left, like all the other places are already decided, right? These are n places and these will be taken by first array elements. So this is nothing but n plus m c m, or you can also do this as n plus m c n. Both of these are valid. This is nothing but number of ways to select m positions out of these number of positions. So now what we have to do, see, once we get this, that okay, there are these four towers that are needed to be built at this city, and afterwards these are the towers that are needed to be built at this exit city. So first of all, we'll have to put one extra element in for this city. Why? Because we are building a brick factory also, and then we can calculate the number of ways to do this. Finally, we'll have one way, such as let's call this is one of the ways, like circle, then there are these 4, and let's have a minus this also. This is nothing but, in this denotes that at this operation we built it a brick factory at exit city, and we have 1, 2, 3, and let's say 4, and 1, 2, 3, 4. So let's say this was the ways once I got returned from this city. Now once I went to this city, then again let's say there are these triangles. So now again I have to merge, and for this, like this will come before these triangles. Why? Because for this city, again, I'll have to build one factory, right? Brick factory. So that will come before all of these triangles, denoting that these are the towers that are going to be built. And this denotes that first, before building these factories, I need to build, like before building these towers, I'll have to build a brick factory. So again, I have 4 elements in this array, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements in this array. So what I have to do, 9 plus 4, C4. So afterwards, and these are the number of ways to combine these two array, but the final number of ways will be, in this case, it's only one, but ways of this, you'll also have to multiply. Like, let's say you have ways here also and here also. The total number of ways that you had here needs to be multiplied here, right? Because there can be permutations. It's up to you. Like, let's say there was one more level here. So for just one level, your number of ways is just one. But if you have two getting multiplied, then you have options, right? You can either first focus on this city, like build towers here or here, or maybe simultaneously. So this will be much more clear when we look at the code. Otherwise, I'll keep on going and you won't get anything. So this is nothing but this code is for calculating NCR. That is number of combinations. So let's look at the actual code. So first of all, I'm taking n as input, then I'm taking array A as input. So these are the number of towers that are required to be built in each of the cities. Then I have this tree and I'm taking U and V. That is, these two cities are connected via road. Then need tower is nothing but you don't actually require this. This is nothing but, like I said, we are not actually worried about those cities that don't require any tower, that either don't require any tower and they also don't require any factory, because none of their child nodes have a tower that is needed to be built. So initially everything for each city, it's 0. And in case any child node or this current node requires a tower to be built, then we'll have need tower is equals to 1. Then these are the vals. Vals is nothing but the total number of ways. So, and total is the number of towers that are built either in city, like in all the subtree of node U. So total of I will give me the total number of towers that are built in the subtree of I. Then this is the final DFS2 function. So in this, first of all, total of U is nothing but the number of towers, right? Then what I'm doing for each of the child nodes of U. So first of all, if this is a parent, simply continue. Otherwise, if there is no need of tower in city V, then simply continue, because you don't actually have to go to that city. Otherwise, move to that city. Then once you return from that city, what you have to do, first of all, vals of U is getting multiplied. These are the number of ways to combine the towers getting built at city U and city V, right? NCR of total number of towers at city U plus total number of towers at city V. And you can either have this as total of U or total of V, it doesn't matter. And this is taking as modulo. Then vals of U, you also need to multiply it by total number of ways to arrange these towers or operations at the city V. So you multiply your total number of ways at city U by total number of ways at city V. This was just arranging like those operations or merging those two operations. And within those two operations, you could also permute them, right? So this is those permutations. Finally, since now tower U, like the total number of towers at city U, like that array, since after merging, like when we merge those two arrays, my final array at city U or node U has increased, right? So that is why I'm incrementing my total U by total V. And what is this total U plus plus? So this is nothing but, see, as city U, we also had to build one one brick factory, right? So when we were currently on city U, we didn't have to worry about it. Why? Because when we are at city U and any other, like any city or any node which occurs at in subtree of node U, it automatically will all, like, for any tower which is built in any of those cities, by default those towers will always be built, like, let's say we are currently at this city. So for any towers which are built in this part of our, like in this part of our tree, all of those towers will by default be built after the brick factory is built at this node, right, or this city. So at till this point we were not considering our brick factory, but now once we move to this city, now we have an option, right, whether or not, like, we have, let's say, three three towers that are required to be built at this city. So we have an option: either we built one tower and then built a brick factory here, otherwise build two towers or no towers. Like, we can decide when to build this brick factory, right? So that's why once when we are returning from this current node, I'm increasing my total of u. So this will be actually be used for the parent, because for parent this uth node will be the vth node. So this will be used here for the parent node. And finally, once we return from this dfs function call, I'm printing this vals of 0. So this is the total number of ways that we can have, such that we get the minimum number of operations to complete this project. So I know this is, like, it seems pretty confusing because there's too much maths in this. Like, it's not too much if you just write it on a paper using pen, you'll get it. Like how we are getting these two. You just need to make sure that you know the formula, that for merging two arrays of size n and m, if you want the relative order of the elements in each of those arrays to be same, then this is the formula. So is this clear? Okay. So that's it for today. Thanks for joining, and bye.